So remember, when we are looking at means, so remember, proportions is always the test. When we're looking at means, we are looking at, do we know population standard deviation? So when we have the t-distribution, what does that mean? That means we don't know population standard deviation. We either have sample standard deviation or we have to find it by using the calculator. So this one is a little bit different than the way that we use z-distribution, and in some ways it's a little bit simpler as well. You still have to verify or figure out your hypothesis and figure out is it a one or two tail test, okay? You have to verify the following requirements are satisfied. So remember, it's got to be random, representative, and either it's normally distributed, it tells you in the problem it's normally distributed, or n is greater than or equal to 30. The formula for your test statistic is right there. Finding the p-value is actually probably the one thing that we're not going to do. So we're not doing 4A. We are going to do 4B and 5B. Because the p-value is harder to find, and I don't have a table for you like I do with the z-table. So we're just going to use the test statistic instead. It gives you the same answer no matter which way you do it. And then the conclusion is going to be the same that it was with proportions. Example 1, find the t-value for a right-tailed hypothesis test if we have 15 degrees of freedom and alpha equals 0.10. So when we're looking at this, guys, if you look at the top, it says two-tailed area and one-tailed area. You match up your alpha based off of if it's two-tailed or one-tailed, so pay attention, okay? So then that's the column you're going to use, and then you're going to degrees of freedom. So on this one, if I have 15 degrees of freedom, not n is 15, but my degrees of freedom is 15, and I'm looking at alpha equals 0.10 for a right-tailed test, so one-tailed test, I am going to have 1.341. So right-tailed, which is a one-tailed test, then I'm going to get T star equals 1.341. If you're looking at this, so right-tailed, this is the value 1.341. So the shaded region that I have drawn is called the rejection region. If your critical value, the value that you use the formula for in step, 3, I think? Yes, in 3. If that value falls in the shaded region, it is going to mean you reject H naught. Does that make sense? Okay. For a left-tailed test, you're going to, again, look on here, which you're like, but it's the same number. Left-tailed is negative. You use the number from the t-chart and make it negative. So T star is negative 1.341. So again, if you look at this, this is T star. So I am looking in my rejection region. It means that my test statistic is less than that in order to fall in the rejection region. Does that make sense? Okay. And then a two-tailed test.
1.753.
Okay. T star is 1 plus and minus 1.753. So for a two-tailed test, my rejection region is both sides. So this is negative T star, this is positive T star. So I'm looking, does it fall in either of those? Is it either bigger than the positive or less than the negative? So if the degrees of freedom we desire are not available, we follow the practice of choosing the closest number of degrees of freedom available. In addition, the last row of the t-table provides a z-value from the standard normal distribution. So the very bottom is for degrees of freedom that are more than 2,000. So if I have 3,000 as my n value, you would use that infinity bottom number. Does that make sense? Yeah? Okay, perfect. And the reason why is because if you look at that chart, the bigger n gets, the more normal and the more that the T chart starts to look like the Z chart. So that's why we just use that. According to the Centers of Disease Control, the mean number of cigarettes smoked per day by individuals who are daily smokers is 18.1. Do retired adults who are daily smokers smoke less than the general population of daily smokers? So H1 is testing is mu less than 18.1. So therefore, what's my null?
It's greater than or equal to?
Greater than or equal to or equal to. Doesn't matter which one you put. To answer the question, we obtained a random sample of 40 retired adults, so n equals 40, who currently smoke daily and record the number of cigarettes smoked on a randomly selected date. The data result in a sample mean of 16.8, so X bar is 16.8, and a standard deviation of 4.7, so sigma S, or SX, I don't care how you write it, is 4.7. Is there sufficient evidence at the alpha equals 0.1 level of significance to conclude that retired adults who are daily smokers smoke less than the general population of daily smokers? So alpha equals 0.10. Okay, verify your requirements. Is this random? Yes. Is it either following a normal distribution or is n greater than or equal to 30? N is greater than or equal to 30. Okay. Compute the test statistic. So T star.
Are you ever going to give us one where the requirements are true?
Probably not. No. All right. Unless I'm asking at the end, are your results valid? Then I might say do it. And then, okay, now, because of the fact that they're not, you can state, well, my results may not be valid because my sample's not large enough or whatever. T star is X bar minus mu divided by sigma divided by square root of n. So go plug that in your calculator.
I got that too.
Negative 1.75. So that is my test statistic. So scroll down. Again, we are not doing A, so we're going to just ignore that. So find the critical value. So my degrees of freedom are what?
39.
39. At the alpha equals 0.1, what type of test is this? Left-tailed. So go to your T chart. Go look up that T value. So right, T value is 1.304. Because it's left-tailed, make it negative. Now, our decision. So if you need the visual, this is negative 1.341. Where is negative 1.75? To the left or right of that? It's right here. Does it fall in the rejection region? Yes. So negative 1.75 is less than negative 1.341. Reject the null. Or H naught. Don't care how you state it.
Where did we get negative?
I mean, it doesn't change the answer, but
3, I don't know where I got negative 1.341 at. Sorry about that. Yeah. Try that again. All right, there we go. Is that better? Thank you. Yeah. All right, so my conclusion. There is sufficient evidence to conclude that retired adults who are daily smokers smoke less than the general population. All right. Number 3, statistics students believe that the mean score on the first statistics test is 65. A statistics instructor thinks the mean score is higher. He samples 10 statistics students and obtains the following scores. He performs a hypothesis test using a 5% level of significance. The data are assumed to be from a normal distribution. So, my H1 is that the mean is greater than 65. My H0 is that the mean is 65. What type of test is this? Right-tailed. And then you need to go put the data in, and you need to find your mean and standard deviation. Remember, when you're using the calculator, your standard deviation is the one that says SX. And then the N is 10 because he used a sample of 10. So X bar, you should have gotten 67. SX, you should have gotten 3.1972.
I didn't know how many decimals to go back to.
So, are my assumptions good?
Yeah.
We said it said it came from a normal and it's a random sample. There. Number 3. So first I have 67 minus 65 divided by 3.1972 over square root of 10. So you should get 1.978.
Do we round that?
I would leave it there. When I look, I have degrees of freedom is 9. Alpha is 0.05. So my t-value is 1.833. Everyone okay with that? So again, if you want the visual, this is right-tailed. This is 1.833. Where does 1.9878 fall? Is it in the rejection region or not? Yes, it is. So we're going to reject the null. So my conclusion is there is sufficient evidence. Bless you. To conclude the mean score of the test is higher than 65.
That's exactly what you thought. No, man.
Okay, go to number 4 on your own. I think you did most of this on your own, but go ahead and do number 4 on your own, the whole thing, and then we're going to go through it.
We reject
Okay,
Oh,
so
this
what is
this
H0?
3 on 2.
What's H0?
Okay.
one or greater than one.
No, H0, not H1.
Equal to
Mu is less than or equal to 1. H1 is mu is greater than 1, so this is
Right.
right-tailed. So my calculator tells me that X bar is 1.04 and SX is 0.0659. So when I calculate my test statistic, 1.04 minus 1 divided by 0.0659 divided by square root of 11, and I get 2.0131. Agreed? Okay. You're using your t-value. If n is 11, my degrees of freedom is 10. The alpha is 0.05. So what is my t-value? 1.812. So when I draw, this is 1.812. There is my rejection region. Does it fall in it?
No, we failed to.
2.0131 is greater than, so it's in the rejection region. So reject the null. So my conclusion is there is sufficient evidence to support the claim that the conductivity is greater than 1.
On like our tests and quizzes, can we just say there is sufficient evidence, or do we have to write out the whole thing?
Please.
I'll probably have you stop at reject null or fail to reject null. I might have you write the conclusion out once or twice and you'll write the whole thing then, but I'm not going to ask it on every problem.
So if it's right tail test, if it's greater than, you keep it. If you reject it, if it's a left tail test.
Less than, and then if it's two-tailed, which we're about to do, you have to look at it. Doesn't fall in either rejection region. It's either greater than the big one or less than the smaller one. No. It'll make sense whenever I show it to you. All right, next one. Example 5. To test H naught, mu equals 100 versus H1, mu is not equal to 100. A simple random sample of size n equals 23 is obtained from a population that is known to be normally distributed. So if x bar equals 104.8 and s is 9.2, compute the test statistic. So we have 104.8 minus 100 over 9.2 divided by 20 square root of 23. So our test statistic is what?
Certainly something.
2.50. All right. If the researcher decides to test the test hypothesis at the alpha 0.01 level of significance, determine your critical values. Okay, so remember, this is a two-tailed test because it's not equal to. So degrees of freedom
2.819.
is 22, alpha's 0.01, so T is plus and minus 2.819. Right? What is your decision and why? So draw your rejection region. This is negative 2.819. This is positive 2.819. Where does that number fall? Is it in the rejection region or not?
No.
It is not. So 2.50 is basically right there, somewhere, outside of that shaded region. Therefore, we will fail to reject H naught. So my conclusion, there is not sufficient evidence to support that the mean is not 100. Now, let's review from last chapter. Construct a 99% confidence interval.
I forgot.
So, remember that is going to be x bar plus or minus t star times sigma over square root of n. So, x bar is 104.8 plus or minus
Is this going to be on the test?
2.819. There's going to be at least one problem like this on the test. Times 9.2 over square root of 23. Remember, you don't have to have the formula memorized. And so you just plug it in, find your confidence interval. 99.39 to 110.21. And then, reminder of how to interpret that interval. We are 99% confident that the true mean, it's important that you say those words, is between 99.39 and 110.21. Omit.